So in the previous two lectures, we discussed about study designs in quantitative research. We have already covered study designs in quantitative research based on number of contacts with the study population. That is, we have 1-point contact, 2-point contact, and 3-point contact. This is done. Based on the reference period of study, that is retrospective, prospective, retrospective, and prospective, that is also done. Based on the nature of investigation, in the previous lecture, we discussed about experimental study designs. So all the experimental study designs enumerated here were discussed in the previous lecture. Now in today's lecture, we will discuss about semi-experimental study design. That is also called as quasi-experimental study design and other designs which are not classified under any of these categories. Okay, so basically we have three basic categories based on the number of contact points, based on the reference period of the study, and the nature of investigation. These are three basic categories of classification of study designs in quantitative research. Those designs under quantitative research that cannot be classified under any of these categories are labeled as other designs in quantitative research. And they are across over comparative design, replicated cross-sectional design, trend studies, cohort studies, panel studies, blind studies, and double-blind studies. So in today's lecture, we will discuss quasi-experimental design, that is semi-experimental study design, and other designs that are used in quantitative research. Now coming to the first, that is quasi-experimental study design. So quasi means basically literal meaning of quasi is resemblance. It resembles to experimental study design, but it is not a true experimental study design. It is just resembles a study design. The quasi-experimental design is a design that resembles an experimental design, but it is not a true experimental study design. So what are characteristics of true experimental study design that we have discussed? The foremost characteristics, or we can say hallmark of any true experimental study design is intervention. So intervention or manipulation is always present in case of true experimental study design, right? So intervention means we have some kind of intervention. We study cause and effect relationship in case of experimental study design. Experimental study design, the purpose of experimental study design is to see the relationship between cause and effect. Okay, we want to assess what is the relationship between cause and effect. So we intervene with the cause. So our cause is the intervention. Like my example was related to electric vehicles and the air pollutants. So if I introduce electric vehicles, there is possibility that air pollutants will go down. Okay, so electric vehicle is an intervention. Electric vehicle is a manipulation that I am introducing so that I will see the effect on air pollutants. Okay, so intervention is a hallmark or manipulation is a hallmark of experimental study design, true experimental study design. Apart from intervention or manipulation, randomization is always present in case of true experimental study design, right? Also, control group is present in case of true experimental study design. So if you see true experimental study design, there are three important hallmarks of experimental study design that is called as true experimental study design. First is intervention and manipulation. Hence, we call it as cause and effect relationship or the study which assesses cause and effect relationship. The second is randomization. We select the participants. We enroll the participant based on the random selection process. We do not have convenient sampling. We do not have purposive sampling, but samples are selected based on the random sampling method. Means each and every participant in the population get equal opportunity of getting selected for that particular study. That is randomization or random selection of the samples. And the control group. So we have already discussed why do we keep control group in true experimental study design, so that we want to control various effects. Okay, effects which are produced by extraneous variables or random variables or chance variables, or there are so many other things like conditioning effect or reactive effect or maturation effect. All those effects we control with the help of control group, right? So that were the characteristics of true experimental design. Now, how this quasi-experimental design or semi-experimental design, which resemble experimental design, but it is not true experimental design, how it differs from true experimental study design. So intervention is always present. As we are calling it as a experimental design or semi-experimental design, intervention is also hallmark of this quasi-experimental study design. Means intervention will present all the time in case of quasi-experimental design as well as true experimental study design. Okay, randomization, random selection of sampling is not seen in case of quasi-experimental study design. In the previous lecture, when we were discussing about experimental study design, that time Dr. Amrita raised one question that she had some group of patients wanted to have some intervention. and she wanted to select the patients based on the convenient sampling. So how do you select if you want to conduct an experimental study design, but you want to select a convenient sample, not random sample? Is it feasible? Yes, it is feasible with the help of quasi-experimental design, but that is not feasible with the help of true experimental design. You are doing your intervention, but the samples selected are convenient samples, purposive samples. You have purposively selected that samples. Okay, these are not randomly selected samples. Hence, it is called as a quasi-experimental design. So important difference is randomization is absent in case of quasi-experimental study design, and control group is optional. Okay, so control group is always present in case of true experimental study design, while it is optional. It may be present or it may not be present in case of quasi-experimental study design. Okay, so these are the differences, so basic differences, and we will understand these basic differences based on the different examples. Now coming to the types of quasi-experimental designs, when we'll discuss types of quasi-experimental study designs, you will understand the different examples and how to relate it. The first type of quasi-experimental study design is non-randomized controlled experimental design. In some books, it is also labeled as non-equivalent comparison group design. So non-randomized control experimental design is also called as non-equivalent comparison group design. Second is pre-test, post-test design. Third is interrupted time series design. And fourth is combination design. So these are types of quasi-experimental designs or semi-experimental designs. So whenever you are working in clinical settings, whenever you are working with the patients, whenever you are working with human participants, okay, any field, maybe it is health field, health science field, management field, or any other field, when you are working with human participants, in that case, it may not be possible to have intervention and random selection of the samples. Sometimes you have to apply purposive sampling. Sometimes you have to select sample based on your convenience or based on the convenience of the human participants. In that case, many times you can use such kind of experimental design that is called as quasi-experimental study design. Okay. Now, in detail, we will discuss one by one about these four types. First is non-randomized controlled experimental design, also labeled as non-equivalent comparison design. So basically non-randomized word is means the sample selection is non-randomized sample selection. So sampling process is non-randomized means convenient sampling process is applied here. It is controlled all experimental study designs, whether it is true experimental study designs or semi-experimental study designs, all they are done under controlled setting. Means you have control on your experiment because you are applying intervention. Intervention is introduced by the investigator. Intervention is introduced by the researcher. Hence, you have a control on your work. Okay, you have control on your cause. You have control on your intervention. Hence, all these, like whether it is true experimental study design or quasi-experimental study design, these are done under controlled settings. Okay, so the word control, experimental, definitely it is experimental study design, right? Now, non-equivalent means non-randomized. So what is non-equivalent? Non-equivalent is nothing but the way of selecting the sample. So it is non-randomized sample. Comparison groups. Comparison means here you have groups, you have a comparative groups. Hence it is called as non-equivalent comparison group design because you have a comparative groups here. And that is the reason it is called as comparison group design. Now, what we do here, we are testing two groups. So we have two groups and we compare these two groups. But we compare these two groups before comparing. What we do not randomly assign the participant. Participants are not randomly assigned in this particular experimental study design. Selection by non-equivalent or non-randomized way. Okay, means you are selecting the participants, whether it is human participants or animal participants. You are selecting those participants in a non-random way, but in a convenient way, or whatever is convenient for the sampling process. That convenient method is used. Now, suppose just example I would like to give regarding your batch. Now, suppose there are 40 students in this class. Some students, they are a part of university. They are every day they are coming to the university because they are staff in the university. Now I want to assess which teaching methodology is better, whether it is offline teaching or online teaching. This is intervention. Teaching is intervention, whether it is offline teaching or online teaching. It is a type of intervention. Now I want to assess whether offline teaching is better or online teaching is better. What I will do, suppose in a random way, I want to select the sample in a random way. What I will do, I will create the random numbers out of 40. I will select group A for offline and group B for online. So that is the ideal way of experimental study design. Now, what is happening? There are some people who are full-time staff in the university. Every day they are coming to the university, and for them coming offline once a week, it is possible. but there are people who are registered from different parts of country. Maybe people are from Himachal Pradesh, maybe from Kerala, or different parts of Maharashtra, or different parts of Rajasthan. So people are enrolled from different parts of the country. Every week a person cannot travel from Himachal Pradesh to here or from Rajasthan to here. It is difficult for that person, right? So what I will do, what is convenient for me, those people who are working in the university, that group will be offline lectures. I will select those people for the offline lectures. Okay, means I have selected sample based on my convenience and samples convenience or participants convenience. So one group that is offline, those who are working in the university, those will come for offline lectures, and online who will attend, those people who are away from this particular area, who are away from university, or those who cannot come every week to the university. That second group will be online teaching intervention, right? So convenient sampling is the way in case of it, because this is requirement of the study. If I want to do it in experimental way, if I want to conduct experiment, if I want to have that intervention, but I cannot do it in a randomized method. I cannot select sample in a random way. In that case, we apply convenient sampling and we label it as a quasi-experimental design rather than true experimental study design. Okay. Now, what is the drawback associated with this? What I am doing the sample or sampling in a convenient way. Like those who are coming to the university. Now, suppose those who are coming to the university, most of them are teachers. Most of them are associated with the teaching part. So there is always possibility that they are aware with the research methodology. They are aware with the research processes because they are teachers. Some of them are professors. Some of them are associate professors. They are teaching students. Some of them are also teaching research methodology as a part of their curriculum or as a part of curriculum of their students. Hence, what I am doing, I am purposely selecting the samples for offline thing and online thing. In online, there is possibility that many people may not be related to academics. People may be from industry, people may be from some organization which is non-academic organization. In that case, I am introducing bias because already those people who are exposed to research methodology, already those people who are teachers, already those students who are teachers, they are aware about the research methodology knowledge. So the intellectual level or maybe their understanding of research methodology may not be the same in both the groups. So that is the problem with this kind of study. That is a drawback. Like there is no internal validity. You cannot have internal validity when you have this kind of problem. If you want to introduce internal validity, matching is mandatory. Matching is mandatory in terms of what? Suppose I have all people who are teachers. Like most of students are teachers. They are working with the teaching organizations, teaching colleges who will come for offline or who are the part of the university. In online, I should match for their age, I should match for their teaching capabilities, or I should match for their academics. Suppose those who are from academics, even for online, I should select people from academics, those who are attached to academics, or I should match some intellectual levels for both the groups. Means matching is important parameter, matching in terms of their intellectual capacity, matching in terms of their exposure to research methodology is important. Then only I can have that internal validity. Otherwise, my study will lack the internal validity. You cannot replicate this study. You cannot have truthfulness about study. It will not give you true results. Okay, the results will be false results because it will lack the internal validity because of this unmatching or because you are not applying a random sampling process, right? So that is the drawback which is associated with this non-equivalent comparison group design. Otherwise, it is good in situation where it is not feasible to have random pickup of the samples or random sampling method is not applicable. In that situation, you can use this kind of sampling method. Only you have to take care of internal validity, which is associated with such kind of study design, right? So once again, I will repeat, it is non-equivalent comparison group design, also called as non-randomized control experimental design. Samples are selected in a non-random way or based on the convenient sampling method. So random sampling is absent. We generally test two groups in this method. So there is comparison between the groups. The drawback is internal threat to validity of the data. If you do not have matching, how can you control this bias by matching between the groups? So whatever groups you have two groups, you have to match the groups. So just now I give example of offline teaching and online teaching. So for both offline and online teaching, whatever participants you have, suppose you do not have that many participants. Like in online teaching, only there are 10 participants who are exposed to academics, who are into academics, or who have some knowledge about research and methodology. Then you can match like you can match their characteristic, maybe 10 people or 10 students for offline and 10 students for online. Okay, so if I want to have my intervention, if I want to assess the efficacy of my intervention, in that case, you can have this solution. Yes.
So I just understand. Usually when we do matching, suppose if we're doing for age or BMI, okay, so at times we cannot get the exact match. So there is a lot of ambiguity. So is there any specific like a standard deviation of plus or minus two or one that is permitted?
No, relative matching you can do, and the factors like you cannot have matching for all the factors. You match for important factor. Here, important factor is what? Age may not be important factor in my example. Age doesn't matter because once you attain particular age, you already pass your postgraduate program. Here, important is exposure to research methodology. So you identify the most important variable. If BMI is most important for you, then go for BMI thing. If age is the most important, because you see which variable is affecting your outcome variable or your dependent variable. So whichever
Except some like when we're talking about healthcare, sometimes we can't get exact parameter like if in two people.
you can
Every
have
person
relative
is-
matching. You can have relative
So
matching.
how much relative is acceptable in the
That is the physiological limit. Suppose BMI has particular physiological limit. That physiological, like blood pressure. Blood pressure is always a range. So all these, if you see most of the hematological values, biochemical values, or test results, they are in the range. So you can match in the range, not out of the range. Exact matching may not be feasible.
study on young adults. So there is a classification of age where young adults are defined between the age group of 18 to 34 something, 34, 35 years. So in that, if I take one participant who is 24, another who is 34, both are in the same age group. But can I still match them?
No,
or for a 24 wala guy, I need a 24 age guy
no,
only.
then you see the physiology. Like suppose if after 30 years of age, if there is maybe 30% of reduction in overall BMI or overall physiological parameters are going down, then you cannot match that way. Maybe you can keep smaller gaps.
34 wala, both are young adults, but
No, but 18,
certain parameters are will be different. Like for
definitely,
18
definitely. The metabolism, you see, maybe you can even can ask the physiologist. So maybe I can just give example. Metabolism. Suppose metabolism is reduced by 30% after 30 years of age. If there is a literature review that is saying that after 30 years of age, metabolism is reduced by 30%. Okay. Then you cannot match person who is 18 years and person who is 30 years, 34 years. Similarly, suppose if we have a race or if the people are playing football or some other games, you have to match for that particular age. 18 years boy will always run faster than the person who is 34 years.
Sometimes
It's
so
always
if
possibility.
Comparison between a badminton player group and healthy controls who are age match but not involved in any sports. So if I'm taking a 19-year-old badminton player, what we usually do is we try to take the same age match. So 19-year-old only person,
It's always
boy
better.
who
It
is
is better.
not playing.
When you are here, you are dealing with the physiology. You are dealing with the physiological influence because see activity when you take or if you see the sportsman, they retire at the early age. Like suppose the sportsmen, if you see they retire at the age of 35, 38 or 39 years of age. By that time they retire. We start our career at that age and they retire by that time. So it is always a group. Like suppose you are having sportsmen, then you should match for that particular age. Maybe 18 years for 18 years or 18 to 19 years, 19 to 20 years. You can have smaller gaps in such condition. Yeah. It is the requirement of your study. It is requirement of your research.
So when we collect data, how is it? Usually we collect the entire cohort, first the experimental, and then we search for control. I mean, this is
In
something I've
experimental
always wanted to
experimental
know.
study design, you have to assign the participant randomly. You have two groups, experimental group or test group, and you have a control group. Participants you cannot assign in a non-random way. You have to assign participant randomly. Suppose you have today 5 participants. Randomly you assign into group A and group B or test group and control group. That assignment is important. And then you conduct your study. Otherwise, what you suppose you have a study in which you are having intervention simultaneously in both the groups. But first you assign the participants and then you have simultaneous intervention.
Suppose I have 4 people who are 20 years of age in my sampling frame, then randomly I can assign two to one group and two to the other.
No, once you have sample, like see randomization that we will discuss in statistics, but you ask, I will tell you. Now we randomize random sampling process. What we do, suppose your sample size is 100. So for 100 sample size, you will create a random numbers, 100 random numbers. and 100 random numbers you will divide into two groups. Suppose you want to divide them equally. Sometime what happens, you equally divide into group, or there is unequal division. It is based on your study design. Suppose we consider there is equal distribution of samples. Then what you do, you create the random numbers and randomly you assign the groups. Already you assign the group. Participant number one will go to group A, participant number two will go to group B, participant number three will go again to group B. So that random table, randomization table, or computer generated random numbers are available. That will tell you which participant will go to which group. So you need not have to do anything. You will have third person, or even you will have a chart. So participant one comes, he will go to group A, participant two group A, participant three group C, group B. So that way you can.
But in this, sometimes the matching may be lost. So as she said, if the entire sample has an age range of say 18 to 45 years, then only if I randomly distribute them into two groups, then one group may accidentally end up having younger people as compared.
No, sample should be of that particular age group. Suppose you are
So
working on
within that,
athletes, 18 to 20 years of the age at least. Both the groups will have same. Suppose you take 100 people, 50 for experimental group and 50 for control group. All those are athletes. No, that range should be smaller. In your case, when you are testing for sport activity, you cannot have compare person of 18 years of age with a person of 30 or 35 years of age. It will difficult. Smaller age group, because it is outcome variable. It is going to affect the person who is 18 years of age. He will always perform better, whether it is cycling, whether it is any other game. He will perform better than a person who is 30 or 40 years of age. It is a physiology. You cannot change that thing. Whatever you do, so it will introduce bias. Even one or two participants will have bias because of that.
Because this is a common problem we encounter even.
No. First, you have a compact group, create a cohort group of 18 to 20 years, and then randomly assign into two groups, test group and control group. This particular variable is most important for your study. This is going to affect your outcome variable. Second design is pre-test and post-test design. Now, pre-test and post-test design, the name itself suggests that, again, it is a type of a non-random or quasi-experimental study design. But here we conduct a pre-test, we have a baseline data, and then we have our intervention. After intervention, we collect a post-test data. Then we compare baseline data with our post-test intervention data. Okay. Again, since it is a quasi-experimental design, it is done in a convenient way, or the samples are not selected based on a random sampling method. It tests the effect on outcome or dependent variable before the intervention and after the intervention. So you see before the intervention what is happening and after intervention what is happening. Now I will just give example regarding your batch only. Suppose there are 40 people in your batch. Now next part of our lecture, these are the research methodology lecture. Next part will be lectures on statistics. Now statistics has different things, like we have manual statistics or we have statistics based on the computer softwares. Suppose we have different kinds of software. SPSS is the most commonly used software. Now, when you want to use software, when you want to perform on the software, we need people or we need students who are good at variables and measurement scale, because all these softwares, the values are assigned or the tests are performed based on the variables and the respective measurement scale. Now, if I want to select only 20 people from your batch, how will I select? I will conduct a pre-test for your batch. So how will I conduct a pre-test? I will give certain questions on variables and measurement scale for your batch. Out of 40, who are the topmost top scorers, 20 top scorers? I will select those people, and then I will take them for this SPSS test, or I will teach them SPSS. Okay. So what I did, I applied pre-test. Pre-test, it is based on what? It is based on certain assumption. It is based on requirement of the variable which is affecting. Which variable was affecting the teaching for SPSS? The important variable here was variables and measurement scale. Already you have gone through variables and measurement scale, but understanding of variable and measurement scale is important if you want to learn the SPSS. I want to teach you SPSS, otherwise it will be blank. Everybody will be blank. So what I have done, I conducted a pre-test. In pre-test, I gave you certain questions based on variables and measurement scale. Those who scored or those 20 toppers, I selected for this SPSS intervention. And then to these 20 people, I taught teach them this SPSS method or research statistics by SPSS or by using SPSS software. Okay, so this is called as pre-test and post-test intervention. After post-test, after suppose after 3 months, if I complete research statistics on SPSS after 3 months, then I will assess both the groups, like which group is performing better or whether SPSS group is performing better as compared to baseline. So baseline data is nothing but for the comparison purpose. But pre-test and post-test design, what again I have done, I have purposely selected the sample. Ideally, when you do experimental study design, out of 40, I should select in a random way, either by lottery method or by generating computer generated random numbers. Okay. By that way, I should select the sample. But what I did, I conducted a test. Why I conducted a test? Because this is the important variable which is affecting, which is the important variable. The knowledge about variables and respective measurement scale is the important variable that is going to affect my outcome variable, that is going to affect my dependent variable. Okay. So that knowledge is important if you want to learn SPSS. If I want to teach you SPSS, that knowledge is important. Hence, I purposely selected sampling. Convenient. This is the convenient way of selecting the sample that, rather than random sample selection process. Okay. So it tests.
Control required for pre-post test design.
It is not mandatory. See, in case of quasi-experimental design, it is optional. Control group is always optional. Control group is mandatory in case of true experimental study design. Okay, so if it is true experimental study design, it is mandatory. But in case of all quasi-experimental design, it is optional. It tests the effect on outcome or dependent variable before the intervention is given and after the intervention is given. Just now I gave you example of SPSS test intervention. Now, pre-test is conducted to identify the participants to be included in the intervention. So what I did, out of 40 participants, those who are good at variables, those 20 who are good at variables, I selected them for this SPSS test intervention. Pre-test data is collected or baseline data is collected, and that is used for comparison after the intervention. So what I have collected, how much knowledge you have, regarding variables and measurement scale. That data I have collected. Okay. And post-test is conducted after the intervention. So I have intervention of SPSS teaching method or SPSS software, research statistics based on the SPSS software. And then after this teaching, after completion of teaching, I will collect the data and I will compare both the data, whether there is improvement or whether your knowledge regarding SPSS is same or it has improved, right? So this is pre-test, post-test design. The important part here is random sampling is not present or random assignment of the participant is not present in case of pre-test, post-test design because it is a part of quasi-experimental study design. Interrupted time series design. So interrupted time series design is what? The word say interrupted time series. Time series means over a period of time, means it is a quasi-experimental study design. It is semi-experimental study design. In this study design, you collect the data at particular interruptions of time t. So the data is collected over a period of time t, over a period of some kind of interventions, and it uses series data in case of series. Now, suppose I want to assess the efficacy of teaching methodology, whether offline teaching is better or online teaching is better. Now you have 6 months in your hand. Okay. Generally, we conduct coursework lectures almost for 6 months. Now, what I will do for first 3 months, I will apply online teaching methodology. And for next 3 months, I will apply offline teaching methodology. So what I will do, I will have interruptions T. T interruptions means what? Every weekly, every Thursday, I'm conducting lectures. So what I will do, I will conduct lecture for 1 week and next week I will conduct a test for that particular topic. Suppose today I am teaching research design or quasi-experimental study design. Today I will teach quasi-experimental design and next Thursday I will conduct the test, both for offline method as well as online method. So for the first 3 months, I am using online method and next 3 months I am using offline method. Weekly I am conducting one lecture and weekly I am conducting the test. Okay, first week is a lecture, second week is a test. So same thing is repeated over a period of time. So I am collecting your data after 2 weeks. After every 2 weeks, I am collecting data regarding your understanding about that particular lectures. Now, after 6 months, I will have data points for online lectures like your assessment. Basically, I will do assessment based on whatever you have written. That assessment will be done. Maybe it will be in the form of marks. It will be a quantitative assessment. So that quantitative assessment I will compare for different data points for online lectures as well as for offline lecture. So here I have a series for 6 months, lecture series for 6 months, and I have different data points which is collected over a period of 6 months for both the methodology for online as well as offline teaching. And then based on the test of significance, we can compare which is the best teaching methodology. We can have average for online teaching and we can have average for offline teaching, and we can compare which is the best teaching methodology for this particular study design. Okay, so that is interrupted time series design. Means you are collecting a data over a period of time. There is a time series, multiple T's are present, multiple multiple data is collected over multiple time. Okay.
So the same group goes through
Same
both
groups,
the
both the
techniques,
interventions,
whatever
both the
intervention.
techniques. Means I will take a topic, similar topic. Suppose we have 8 topics on research methodology. These topics are connected to each other and most similar topics are present. So I will conduct, take first 4 lectures in online mode and remaining 4 lectures in offline mode. And the test will be conducted every weekly or after every 15 days, the test will be conducted and the marks will be given. So we will have quantitative assessment for both online as well as offline teaching modality.
So is this the same? Sometimes we give two different types of intervention to two different groups and then we swap the group.
No. That is
uh,
different. That is
I was getting confused.
no. But
That is-
see, we are discussing quasi-experimental study design. So if you are randomly allocating the samples, then it
Then
becomes
it's
true
not true
experimental
experiment.
design. Then there are no obligations of quasi-experimental study design. In case of quasi-experimental study design, control may be present, control may not be present. Randomization is always absent in case of quasi-experimental study design. So when you are doing randoms assignment of the participants, then it is not quasi-experimental study design. Then it will be true experimental study design, and all the features of true experimental study designs will be applicable.
There is no control group. So now recently we conducted a study of 6 weeks in which there was only one group because it was not feasible to have another group. So in the group of 10 children with special needs, in the first 3 weeks, we worked on one intervention, one aspect. And then we were trying to see the effect of the intervention on the reading ability of the children. And in the next 3 weeks, we added another intervention. So then that fits into this.
Yeah, but was it a random selection of samples or it was convenient sampling? Convenient sampling. It falls into this category. You conducted it for how many months?
6 weeks, 3 weeks and 3 weeks.
3 weeks and 3 weeks of intervention. But and how many observations you collected?
So 3 observations. First pre,
Hmm.
then one at the end of
Intermediate.
3 weeks, and at the end of 6 weeks.
So you compared pre and post, or
Same
Reading only.
observation.
so you compared pre, intermediate with post, or pre with post?
Actually, multiple comparisons we have done. So time A with time B with time C, time A with time C.
Then it will go into the category of interrupted time series design. Otherwise, if you compare pre and post, okay, baseline data with the post test observation, then it becomes pre and post test quasi-experimental design. So this cannot fall into category of true experimental study design. You have intervention, but there is no randomization. Control group you can keep, otherwise it is optional. Control group you can keep or you may not keep. That is possible. So it is a classical example of quasi-experimental study design. Many times in health sciences, this scenario comes. So because you are dealing, most of time you are dealing with the patients, you are dealing with the human participants. In that case, many times this kind of study design is applicable. When you are working with the human mechanics or mechanical things, like my experiment is on electric vehicles and air pollutants. Air pollutants like PM2.5 particle level, PM10 particle level. So electric vehicle again is a mechanical factor, and measurement of this PM2.5 or PM10 again it's a mechanical factor. In that case, this kind of study designs are not required. Like you can go for a true experimental study design, but quasi-experimental study design generally are needed when you are dealing with the human participants. Okay. So it is a variant of pre-test and post-test design because we apply pre-test or we conduct pre-test or baseline observations. We have our intervention, and after our intervention, post-test readings are taken and those are compared. Hence, it is called as variant of pre-test and post-test design. Series of measurements at given interval. So we have an interval of t. Like she just gave example. She had 3 intervals. Okay, interval 1, interval 2, and interval 3. She conducted. She compared A with D, B with C, and A with C. So multiple interventions she compared at collected at interval t, before and after intervention. Okay, so she had collected before intervention, during intervention, and after intervention, and all those things are collected. So it's an example of interrupted time series design. Just now I gave example of offline and online lectures. So how we can have interrupted time series design, quasi-experimental. under category of quasi-experimental study design. Multiple interventions test the consistency of trends in the data. So what is a trend in the data? Well, basically what we are understanding, all time series designs, basically they will give you idea about consistency of the data, reliability of the data, reproducibility of the data, or validity of the data. Whether same data you are getting, whether true data you are getting, or whether that data is reliable, that information is given because you are having multiple interventions. Okay, you are collecting data at multiple points of time. There is interrupted collection. Okay, after time t you are collecting the data, after even again after time t you are collecting the data. Since you are collecting data multiple times with the multiple interventions, it gives you consistency about the trends in the data, consistency about trends in that particular situation or phenomena. It is applicable for maybe any field, whether it is management science, whether it is health science, whether it is technical science. It will give you idea about what is the trend in that particular area. It evaluates whether intervention is truly effective in achieving the hypothesized outcome. So we have some hypothesis. Okay, so whatever outcome we want to achieve, it evaluates whether it is truly effective, efficacy of your intervention. Basically, why we conduct cause and effect relationship, why kind of study or experimental study, because we want to assess the impact of our cause on the our this thing, the effect. Okay, we want to assess the cause and effect relationship. So whether it is a true effect, whether that efficacy is present, means whether electric vehicles are truly effective in reducing air pollution. I will assess with the help of this kind of study design. It is not applicable for my study design because my study design doesn't fall into quasi-experimental study design. Here I am not randomly, here I am not purposely selecting the sample. Okay, it is not convenient sampling. I can apply random selection of samples in my example. But other examples which I just now I give you regarding offline and online teaching methodology. So in that case, it will assess the true effect of this particular teaching methodology, because same teacher is teaching, similar topics are teaching, and under a similar time period. Okay, so time period is same teacher is available, means under similar conditions. So you can test your hypothesis.
Sir, is it similar to longitudinal study?
See, longitudinal study means it is done over a period of time. So it is classified under longitudinal study. One study you can classify in multiple way. Okay, I will go back to the classification. So your study may be longitudinal and prospective and experimental. So your study may be longitudinal, prospective, and quasi-experimental, right? So all these combinations are possible, right? Or your study may be longitudinal, prospective, comparative design, experimental design. Okay, so always whenever you are proposing a study, it will fall into multiple categories. Basically, it is a classification. So most of the areas of classification will be covered for your study design or for your research design.
Longitudinal, it's mostly about the trends.
Longitudinal study means which are done over a long period of time. Suppose you are conducting one experiment over a period of next 3 years. So you will also come to know the trends. But if you want to know the trends, you have to collect multiple interventions. You should have multiple data points should be there. Then only you will understand. If you have pre-test and post-test, before intervention and after intervention, then you will only understand what is happening, like what is the magnitude of that particular problem. But if you want to know the trend, you have to collect multiple observations. Next is combination design. So combination design is combination of non-equivalent and pre and post test design. Just now we discussed about two basic types of quasi-experimental study design. First is non-equivalent comparison group design. Okay, and second is pre-test and post-test design. Third, interrupted time series design. It is a variant of pre-test and post-test design. So we have two basic types of quasi-experimental design. First is non-equivalent comparison group design, and second is pre-test post-test design. Now this combined design is combination of these two previous basic classification, that is non-equivalent design, okay, and pre and post-test design. That is combination of both. It includes test group and control group. Means here we have a control group. In previous design, we were not having control groups. So this is a design, means it is optional. For quasi-experimental design, it is optional. But when you are having this kind of situation where you are dealing with the control group, where your study requires a control group because you want to control some phenomenon, control some effects like extraneous effects, random variable effect, chance variable effect, Okay, reactive effect, maturation effect, conditioning effect. When you want to control all these effects, you should go for a control group. Okay. So in combination design, what we have a combination of non-equivalent study design of quasi type and pre-test post-test of quasi-experimental study design. Here we have test group or experimental group and a control group. In previous designs, we were not taking control group. That was optional here. Here we are taking the control group. Now example, again, it is related to your batch. Suppose I divide you people into two groups, like there are 40 people. I divide you 40 people into two groups to assess the intervention. What is intervention? Teaching. Whatever I am teaching, that is my intervention. Okay. Teaching means I am conducting the lectures. Okay. So that lecture, conducting lecture, that is my intervention. 20 people, I will conduct a lecture. I will give them all study material, my PPT, videos, and these lectures. And remaining, also I will teach them, like I'm teaching you offline or online way. Similar way, I will teach those 20 people. Group B will have a people for whom I will not conduct any lecture. Only I will provide the study material, maybe in the form of books or maybe in the form of PPT. So lectures will not be taken by me. Means I have a two groups. First group is my experimental group or study group where I am giving them all study material. Apart from giving them study material, I am having my intervention. What is my intervention? Teaching is my intervention. I am actually teaching them. I am actually conducting lectures for them. That is my intervention. So experimental will get the intervention and the control group will not get that intervention. No lectures will be taken for the control group. Only they will get the books and the study material. So when we'll compare the results, means how will you assess? We'll conduct the test and based on the marks, we will have quantitative assessment based on the marks, or even we can have qualitative assessment in terms of your understanding about that particular subject. Then we'll come to know which methodology is better, like whether after conducting lectures, you are getting additional knowledge or your knowledge is going down. So that you will come to know after this kind of study, that is combination study design. So what we are doing in combination study design, we have two groups. We have experimental group and we have a control group. We are selecting samples in what way? I will not randomly select the samples. Conveniently, I am selecting samples. Purposefully, I am selecting the samples. Okay, so that is the integral part of your quasi-experimental study design. Because it is not experimental study design or true experimental study design, the samples you cannot select in a random way. You have to have convenient or purposive sampling method for this particular study design. Okay, here we have two group, experimental group and control group. In experimental group, you will apply your intervention. In control group, you will not have your intervention. Okay, and then you will collect the data. After intervention, you will collect the data, and whatever data you are getting, that data you will compare with your control group to assess the efficacy of your intervention. Ultimately, you want to assess the efficacy of your intervention, whether your intervention is working or your intervention is not working, whether your intervention is giving the results or it is not giving the results. To determine the extent of improvement between the test group and control group. So basic idea or basic objective is what? To determine what is the extent of improvement between the test group and control group. Whether test group is having better improvement as compared to control group because of your intervention. Okay, because you are able to perform or because of this intervention, whether you are able to perform better, like the group which is getting the lectures, whether they are able to perform better, whether they have a better understanding as compared to control group or not, that you will see. Both groups will show changes or improvements. Definitely, both the groups are getting basic material, basic study material, both the groups are getting. So they will show some changes or improvement before and after. Okay, in the before and after reading. It is also used to assess whether it is because of intervention or some effects like maturation or reactive effect. Now, it is very important to control all these kinds of effect, maturation effect, reactive effect, conditioning effect, all these effects we have already seen. Now, what is happening? I am giving the PPT, I am giving the reading material. I am asking you to go through this reading material. Now, because of this particular material, because of this PPTs, the people who are good at understanding, they will understand everything and they will equally perform better or they will perform the same way with the other group, those who got the lectures or who have gone through the lectures. Okay, so it is like a reactive effect. Reactive effect is what they are reacting or there is conditioning. Conditioning because of this kind of study material or these kind of books which are given or PPT which is given. So there is a reactive phenomena, conditioning phenomena or maturation phenomena. Maturation phenomena is generally seen when the population is maturing. Okay, in my case, maturation phenomena may not be applicable. But if you have a population, like suppose you are conducting a experiment for 5 years of 5 years period. Today you have intervention and you will collect one more data after 5 years. But after 5 years, suppose that kid is of 5 years of age. Okay, that the boy or girl will be 10 years of age after 5 years. Okay, there will be understanding will be totally different. Okay, their intellectual capacity will be totally different. Their skills will be totally different at the age of 5 and at the age of 10. So the way they will answer, the way they will react will totally be different at these particular age groups. Hence, that is a maturation effect that we have already discussed. So such kind of effects are also seen in this kind of study, and you have to control this. What you have to control? You have to control all such effects like maturation effect, reactive effect, conditioning effect. And how do you control? By assigning the control group. So what is the purpose of assigning control group? The purpose of assigning control group is to control all the effects, whether it is extraneous variable effect, whether it is random variable effect, chance variable effect, maturation effect, conditioning effect, okay, reactive effect. All those effects are controlled with the help of control group. That is the objective of using control group in experimental study design, whether it is quasi-experimental study design or true experimental study design. Okay. So to summarize, we will discuss similarities and differences in true experimental study design and quasi-experimental study design. First, we will talk about similarities in experimental study design and quasi-experimental study design. In both, that is true experimental study design and quasi-experimental study design, intervention is present. So first point is in under similarity, intervention is present. Both, that is true experimental and quasi-experimental study design, evaluate cause and effect relationship. We have a cause, that is intervention, and we assess the effect of that intervention in the form of its effect on outcome variable. Manipulation of variables. Manipulation means intervention. We have some kind of intervention. Okay, so I have electric vehicles. That is my intervention. I want to introduce these electric vehicles to assess its impact on air pollutant. So I am manipulating my variable. Maybe I have electric vehicles. I will add CNG vehicles. I will add petrol vehicle, diesel vehicle, hydrogen vehicle. So I can manipulate with my variables. I can have multiple intervention so that I will have a comparative data at the end of study. So manipulation of variable is present in case of both true and quasi-experimental study design. Both true and quasi-experimental study designs are conducted in a controlled setting. You have control because you have intervention. It is your own intervention. You are introducing that intervention and you have all controlled setting. Now, if I want to conduct a study on electric vehicles and PM2.5 particle level, I know where to introduce this electric vehicle. I will select the area. I will select the comparator group also. Maybe I can select petrol vehicle, diesel vehicle, CNG vehicle, hydrogen vehicle. If I select suppose CNG vehicle or petrol vehicle, what I will do, I will apply same vehicles. Okay, for comparison purpose. Other group will have always control group will have same kind of vehicles. Okay, it will not change. So it is done under controlled setting. So both true and quasi-experimental study design, they are done under controlled setting, and these settings are controlled by principal investigator or researcher, or you are a researcher for your study. So you control the settings of your study. Now, what are differences in true experimental study design and quasi-experimental study design? Random selection of participant is always present in case of true experimental design. Non-random selection of participants. So random selection of participant is absent in case of quasi-experimental study design. May be conducted with or without pretest. So it is not mandatory to have pretest for all true experimental study design, because we have already learned after only experimental study design. In the previous lecture, we discussed about after only experimental study design, where we were not taking this pre-test observations or baseline observations were not needed. Okay, so maybe conducted with or without pre-test, that is true experimental study designs. Quasi-experimental study design, most of time it involves pre-test and post-test data, right? It contains test or experimental and control groups. So we have two groups in case of true experimental study design, which are always present, that is experimental group and control group, or test group and control group. Test group or experimental group means the group on which you will have your intervention. You will study your intervention, that is your test group or experimental group. And control group, that control group will not receive any kind of intervention. That group will not have intervention. Okay, just it will be used to control different kinds of effect which are associated with the study. Control group is optional in case of quasi-experimental study design. Okay, so control group we have seen in case of combined design or combination design. In that case, we have seen the use of control group. Pre-test, post-test design, interrupted time series design, and non-equivalent comparison group design. Either we can take or If not required, we may not take it also. Now, next part of classification. Just now we discussed, I will go back to classification. Just now we discussed semi-experimental or quasi-experimental study design and the types of semi-experimental or quasi-experimental design. So we have covered the entire this part. Okay. So we have covered quantitative research design based on number of contact points with the study population, reference period of the study, and the nature of investigation. Now we are moving to next part, that is other designs in quantitative research which are not classified under these three classification types. Now these are other designs which are commonly used in quantitative research. We are still into quantitative research, okay? So first is crossover comparative experimental design. Second is replicated cross-sectional design. Third is trend studies, cohort studies, panel studies, blind studies, and double blind studies. One by one, we'll go into details of it. First is crossover comparative experimental design. Now, the name itself suggests that it is a comparative experimental design, means it's an experimental design. So you have some kind of intervention to study. It's a comparative experimental design means you have two groups. There is comparison between two groups or more than two groups. So you have a comparative groups and it is a type of experimental study design. Now, what is meant by crossover? So crossover means what? The intervention is crossed over. Crossover of intervention means what? Now, there are certain sensitive topics or there are certain sensitive research problems where you cannot have a control group. You cannot have a control group means I will give you example. Suppose you are working on a group of kids or children regarding their nutritional status, or you want to give some basic nutrition to a group of 100 students or 100 children. Now, suppose you divide into two groups, group A and group B. Now, suppose you want to decide group A as experimental group and group B as a control group. For group A, what you will do, you will feed with the basic nutrition, and group B, you will not give any kind of nutrition. But if you see ethical way or from the ethics point of view, this study is not accepted. Nobody will allow you to conduct this kind of study. You cannot keep one group devoid of nutrition because it is ethically not correct. So in this case, you have to feed both the groups. You have to have your intervention in both the groups. Okay. One more example. Suppose you are 40 people in this batch. We'll go back to Corona era. We'll go back to 2020. Now, suppose I divide your batch into two groups, group A of 20 and group B of 20. First 20 people, I will give coronavirus vaccine and I will see the effect of coronavirus vaccine. Other 20, I will not give. But is it ethically correct? Everybody should have a right. Ideally, everybody should get that vaccine, right? I cannot do this way. Because for my study, I cannot keep those 20 people away from vaccine. Otherwise, they will have ill effect. They will have ill effect of coronavirus infection because they are not getting the vaccine, right? So I cannot keep one group away from that particular intervention. Means it is mandatory, both in whether it is first example or second example. In both the example, it is mandatory to have intervention. Whatever is intervention, basic intervention, that basic intervention is needed. In such situation, when you cannot have a control group, when you cannot keep a control group for your study, you can use this crossover experimental comparative study design. Now, how this is conducted? You have a study population. You will divide this study population into two groups, group A and group B. You will not label it as experimental and control group because keeping control group is not ethical in this case. So what will you do? Both are your test group. So test group A and test group B, or your experimental group A and experimental group B. Now at the beginning or here first you will start with the intervention in group A and group B will not receive any kind of intervention. After time period T or after a period of T, you will stop intervention in group A and you will cross over this intervention in group B. Now, if you see in the beginning, you have intervention in group A and there is no intervention in group B. After time T, you will stop intervention in group A and this intervention is crossed over. Now, this intervention is into group B. So group B is getting intervention and group A is not getting intervention. Again, you will follow group B and group A for particular time T. So group B is getting intervention, you will follow it for T. And then this is crossed over for group A. So there is crossover of intervention. You started intervention in group A for a particular time T. You crossed over to group B. Again, after time T, you crossed over to group A. After time T, again, it is crossed over to group B. So there is crossover of intervention. intervention is crossed over between two groups, between A group and between B group. Hence, it is also called as ABAB design. ABAB design means intervention you start with the A group, then you will cross over it to B. Again, after time T, you will cross over or you will change it to group A. So intervention will run from group A to B, B to A to B. That way it will run, and there is crossover of the intervention. Hence, it is called as crossover comparative experimental design or ABAB design. Okay, so this design was given by Grinnell in 1993, and popularly it is labeled as ABAB design or crossover comparative experimental design. In the crossover design, also called ABAB design, two groups are formed. The intervention is introduced to one of them, and after a certain period, the impact of the intervention is measured. So what we are doing, there is intervention. After time T, we are measuring the impact of intervention. Then the interventions are crossed over, means experimental group become control group and control group become experimental group. Means ideally there are no control group in this particular design. Intervention is given to both the groups, but for that particular time T. So for that particular time T or that particular period T, one group is getting intervention, other group is not getting intervention. But at the end of study, both the groups are getting intervention. The experimental group becomes control and vice versa, sometime repeatedly over the period of study. So when if you want to conduct or if you want to have multiple observation, multiple series of observations, then you can do it over multiple times. Okay, so this crossing over can be done over multiple times. So when you are dealing with the sensitive issues, when you are dealing with the sensitive research problems, where keeping a separate control group is not feasible, where intervention to control group cannot be stopped because of or they cannot be kept away from the intervention because of ethical issues, then in that case, this is the best method where you can have crossover of your interventions. Next is replicated cross-sectional design. So replicated cross-sectional design means what? Suppose you want to have your intervention over next 15 years of time. You have one of your interventions and that you want to assess over 15 years of time. But 15 years of time is a long period. You want to assess long-term impact of your intervention. Now, if you have availability of that particular situation, that particular condition, or that particular phenomena in different phases of intervention, then what you can do, you can collect the data from different phases of intervention. I will just give you example. Now, my topic is impact of electric vehicles on air pollutant. Okay, I want to assess what is the impact of electric vehicles on air pollutants. Suppose in India, we started electric vehicles in 2020. But there are some countries who started electric vehicles long back, maybe 10 years back or 15 years back. Okay. So what I can do, suppose I want to study long-term impact of electric vehicles on air pollutants for next 15 years or next 10 years. What I can do, I can select multiple countries in the world where intervention, this kind of intervention, electric vehicle intervention is started long back. Suppose I will select few countries where intervention is started 12 years back. I will select few other countries where intervention is started 10 years back, some other countries where intervention started 8 years back, 6 years back, 4 years back, and we have intervention which is started 2 to 3 years back. And I will collect the data from these different countries. I will take a cross section of these different countries regarding air pollutants and the electric vehicles. Okay, and I will collect the data on PM 2.5 particle, PM 10 particle, carbon dioxide, carbon monoxide, all these air pollutant data I will collect at different levels of intervention. So the country which started 12 years or 15 years back, I have their data, and the country like us, we started 3 years back. We have our data also. So I will compare the data. What is happening over a 3 years of period? What is happening over 5 years of period? What is happening over 10 years of period? And what is happening after 15 years? Instead of waiting for 15 years, instead of conducting my study longitudinally for next 15 years, what I am doing, I am collecting the data from the situations, okay, from the phenomena which is at different stage of intervention. Okay, means there are different countries which are at different stages of intervention. I have collected their cross-sectional data and I have used that data for comparison purpose, and I can build the hypothesis, right? Over 15 years of period, if you use the electric vehicles, this will be the change. After 10 years, this will be change. After 5 years, this will be the change. After 2 years, this will be the change. So that entire data I have. Instead of waiting for that much of time, I will have the data because I got the different stages of intervention. Okay. And that intervention I collected using my cross-sectional data. So this is the replicated cross-sectional design. So you can see your client group, or you can see intervention, or you can see situation, phenomena, anything you can put it here. And then when you you have initial stage and terminal stage. Okay, starting phase at year 1 and year 15. So we have some people which are at 10 to 15 years of intervention, 8 to 10 years of intervention, 5 to 6 years of intervention, and 2 to 5 years of intervention. So I will collect data from each stage, from each country, from each situation. Okay, I will have data from different kinds of situation, different intervention, different periods of intervention data I will have, and I will compare that data. Select sample from among clients who are at different stage of intervention. So what I am collecting data who is at different stage of intervention. Some is at 15 years of intervention, somebody is at 15, 10 years, somebody at 8, 6, 2, 4. Okay, so that data I'm collecting and I'm comparing. That is called as replicated cross-sectional design. Trend studies, these are one of the most popular studies in all the fields. Whether you take management field, technical field, or you take health science field, these trend studies are very much popular. Technological trend 15 years back, 10 years back, current trend, and what will happen in the future. So when you have this kind of study, when you have a data of past, present, and future, okay, what was technology 10 years back? What is the current technology, and what will be the technology of after 15 years? So when we study that trend, that is called as trend study. So trend analysis is integral part of all the sciences. You take any science and trend studies are the integral part. Trend analysis enables you to find out what has happened in the past, what is happening now, and what is likely to happen in the future. So past, present, and future, when we connect these points by different data points, then these are called as trend study for comparison purpose. What was 10 years back, what is now, and what will happen after 15 years. When we connect these 3 points, or when we connect these multiple points, and when we compare, when we apply test of significance and get some kind of result, then this is called as trend study. So you will come to the trends, trend in the fashion industry, trend in the technology industry, trend in the health industry. Okay, so what happened over last 10 years, what happened over last 15 years. So all these trends analysis or trends are studied with different data point are called as trend studies. What you are doing, you are collecting cross-sectional observations. So every time you are collecting the multiple cross-sectional observations, at each point you are collecting multiple cross-sectional observations, and you are comparing all those observations to assess what is happening over a long period of time, how the trend is changing, how technological trend, how fashion trend is changing over a period of from 15 years to next 15 years, for long period of time, how that trend is changing. But basically you are taking a cross section of that particular time, cross section 15 years back, cross section 10 years back, cross section 8 years back, 4 years, 5 years back, current cross section, and then what will happen in the future, that you will predict. Okay, that is a trend analysis, easy to understand. So you have points for past, present, and future. When you are connecting these 3 points, that is called as trend study or trend analysis. Cohort study. Cohort means a group of population which is having common characteristic. Now you are 40 people in the batch, which is what is common characteristic among you? Yeah, all are particular batch. So you are belonging to this particular batch, PhD batch of 2023. Okay, so that is a common characteristic. Suppose I want to conduct one experiment, or I want to conduct one experiment regarding, or if I give assignment on a research design. So it is a cohort study. Cohort study means I will give you assignment to check or evaluate efficacy of my teaching or efficacy of your understanding regarding whatever you have read. So that is a cohort group. You are a cohort group, right? Means it's a common characteristics. You have some common characteristics, then it is called as a cohort group or cohort studies. Cohort studies are based upon the existence of common characteristics, also called as cohorts. So you are one cohort. Okay, the people from a particular batch, like we have different batches when we study undergraduate program or postgraduate program. Suppose our one batch is one cohort. Okay, during graduation program, suppose you are in first year, your entire first year batch is one cohort, because you will undergo same kind of experiments, you will undergo same kind of lectures, you will undergo same kind of test, you will undergo same kind of examination pattern. Hence, you are having some common characteristics, and that you are a cohort. Both of these study could be carried out either as cross-sectional or longitudinal. Basically, here what is important, the people or the common characteristics among the people, that is important. And whatever interventions you are doing, whatever findings you are collecting, whatever observations you are collecting from that particular group or period of time, or you are taking a cross-section. That is cohort study. Next is panel studies, blind
Sir,
studies, and double blind studies. Yes.
uh, sir, I have a, if like athlete, uh, 400-meter athletes, if we are conducting some data, so that will be conducted as a cohort or it is not considered as a cohort.
But the athlete for which any particular event,
400 meters,
400 men. How many athletes you have?
uh, 20.
And you are conducting, you are collecting observation from all 20, right?
Yes, sir.
Then it is your cohort. Panel studies. Panel studies are similar to trend and cohort studies, except that in addition to being longitudinal, they are prospective. So panel means there is a group of people. There is group of people who are having common characteristics, and you study them in a longitudinal and a prospective manner. Cohort studies you can conduct in a cross-sectional manner also or longitudinal manner. But panel studies, they are always conducted in a longitudinal and prospective manner. That is the basic difference. So panel may be having common characteristics. Panel of people or group of people may be having common characteristics which are followed if they are followed for a long time, and if the data is collected in a prospective manner, then it is called as panel study. In case of cohort study, what you do, you collect data in a cross-sectional way and you collect retrospective data also. But in panel study, you collect longitudinal data, that is a prospective data. Panel studies are similar to trend and cohort studies, except that in addition to being longitudinal, they are also prospective. That is the important theme here. Next is blind studies and double blind studies. Now, the basic concept of the studies that have come from health science literature. So in health science, what is done? Some clinical trials are done. Clinical trials means new drugs are tested. Now, if you see many new drugs, they come to the market. Suppose somebody suffering from fever. We have been using multiple drugs, but the new drugs also come to the market and these drugs are tested on the humans. After animal testing, these drugs are tested on the humans and that is called as a clinical trial under different phases. Now, sometime what happens? There is psychological effect. Suppose you are not well, you are suffering from fever. If you go to doctor or if you speak to doctor, sometimes you feel better. So that is a feel good effect. It is what? It is a psychological effect. You have not taken any intervention. You have not taken any treatment. You have not taken any drug. Still you are feeling better. Why you are feeling better? But it's a psychological effect. You feel I am feeling better. You are relaxed. Okay. So whatever ill effect or whatever illness, it has gone down. You can say magnitude has gone down. It is a psychological effect actually. It is nothing. It has nothing to do with the intervention or the treatment. So sometime you have to assess it when you want to test the efficacy of new drugs. Suppose the new drug has come to the market, the pharma company or doctors want to assess the efficacy of that particular drug. In that case, you should assess the true efficacy. So you should delete that psychological phenomena, that psychological effect, that placebo effect. So if you want to delete that effect, if you delete that effect, then only you will be able to reduce the bias in your study. What is the actual effect of your drug? What is the actual effect of your medicine? Okay. For actual effect, what you have to do? You have to minus the psychological effect. In this case, what you plan a group where actual drug is given and you plan a second control group where drug is not given. But when you are collecting human samples or when you are giving this medicine to the human samples, if you give different kinds of medications, suppose there are 50 people who are getting the drug which is under test and 50 people who are getting different drug. Suppose they are under control group and you want to just give the medicine. Suppose group A, which is the experimental group or test group, you are giving blue color tablets or blue colored capsules. And other group, if you are giving red color capsules, then they will discuss among themselves why you got red color and why I am getting blue color capsule. So if you want to avoid that, what you can do, you can distribute blue color capsule. So these 50 people, test group people, will contain actual molecule, actual that test group drug molecule. And the remaining capsules will be empty capsules. It will not contain any molecule or it will have some inert molecule, which will have not impact on your dependent variable. So in blind study, what is done? The patients who are receiving the treatment, they are not aware whether they are receiving real treatment or fake treatment. Means they are totally not aware. They consider that whatever drug they are getting, it is a real drug. Everybody is feeling. you have a randomization table with you. You randomly assign the people for experimental group and control group. But the control group people or even experimental group people, they are not aware that they are getting real treatment or they are getting fake treatment. Okay. In blind studies, only investigator is aware whether the experiment, who is given what kind of treatment, who is given the real drug and who is given the false drug. Okay. And these are called as blind studies. Okay. So what are blind study? Now it has application into other fields also, but this concept has come from the health science field. The study population does not know whether it is getting real or fake treatment or which treatment modality, what kind of treatment modality they are getting or what kind of treatment, whether it is true treatment or false treatment or it is true drug or true molecule or true medicine or false medicine. They are not aware, and then it is called as blind study. Means patients are not aware, that population is not aware what kind of treatment modality they are getting. Double blind study means what? Now here, invest in blind study, investigator is aware. Investigator means you are the investigator. You are a principal investigator of your study. You are aware of which drug is given to whom. Okay. But in some cases, it is the requirement of the research design so that you will be able to control bias in your study. Okay. If even the investigator knows that these people, they got the drug and this particular group of people, they didn't receive any drug. So there is personal bias, there is interpersonal bias because investigator knows. So he will assess those people in a biased way because that person is a doctor. There are certain clinical parameters that are assessed by that particular doctor. So he will assess in a different way. So there are certain study designs in clinical trial where doctor or investigator is not aware. He is treating the patient, he is dealing with the patient, and he is not aware who received correct treatment or true treatment and who received false treatment, so that he will not bias, he will not introduce his own bias in that particular study design because he has certain clinical parameters to study. Okay, he has to note down certain clinical parameters. So while noting down clinical parameters, he knows that who received treatment and who have not received treatment in blind study because only patient is blind. Okay. In that case, there is possibility of introduction of bias. But if you want that there should not be bias in your study, what you can do, you can have a double blind kind of study, that is double blind study in which both investigator and the patients are blind. Investigator is also not aware who received real treatment and who received fake treatment, and even the patients, they are not aware who received real treatment and who received false treatment. Okay, so that is called as double blind study, and double blind studies are done to reduce the bias in the study. So you will get the pure impact of your molecules on that particular disease under study. In double blind study, neither the researcher nor the study participant know who is receiving real and who is receiving fake treatment. So nobody, both are blind. Okay. Investigator is also blind or researcher is also blind and the participants are also blind. That is called as double blind studies. There is one statistician who will randomly assign. See, you consider your clinical situation. You are from Ayurveda, no? So suppose you are sitting in your clinics, Ayurveda clinic. So there will be a statistician who will create the random number. Suppose you have to select 100 patients. You have to enroll 100 patients for your study. Patient one will come. So your statistician will say that this patient will be group A. He will not tell whether group A is experimental group or group B is experimental group. So he will say that enroll this person under group A. Okay. Next person again enroll under group A. Third person will come enroll under group A. It is based on the randomization chart. And then you are also not aware in double blind study as a doctor, you are not aware. You will receive an envelope in which there will be some tablets. These are randomly given to everyone. And you have to assess the clinical parameters. Maybe you have many clinical parameters, blood pressure or age or some other clinical parameters related to your study. So all those parameters you have to assess and you have to record it. Means you are not aware which patient received what treatment. If you are aware, then there will be bias. Suppose your outcome variable is like your thinking will change, your perception will change, your observation will change. To reduce that, both are blind. The doctor is also blind or researcher is blind and patient is also blind. So nobody is aware, only statistician. But statistician is not coming here. Okay, he's sitting distantly and he's just telling enroll in group A, enroll in group B, enroll in group A, enroll in group B. That's it. And you are randomly like you are giving those this thing envelopes with the tablets.